Welcome back. Now that we understand what large language model is, we need to address the most common question I hear. How does it actually work? Or how does it actually do what it does? Is it magic? Is it actually thinking? To be a truly effective AI powered professional, you need to understand the basic mechanics. When you understand the machinery, you stop being surprised by its mistakes and start being impressed by its potential. Let's break down the engine and the sequence that creates this digital intelligence. All right. We have seen a glimpse of this in the previous class, but it's okay to reinforce it again. Now, think of an LLM as a high performance engine built on three raw ingredients. All right. We've referenced it in the last class. One, massive amounts of data. This is the model's live experience. It has to read trillions of words from classic literature to contemporary code. This is how it learns the pattern of human thought and language. All right. So the next is the architecture. You have probably heard the term transformer, all right, from the next class, transformer architecture. This is the structural design of the model. Unlike older AI, the transformer allows the computer to look at every word in a sentence simultaneously to understand their relationship. Now, the third is what? The parameter. These are billions of fine-tuned weights or settings. Think of this as the model's intuition. During training, the model adjusts these settings until it can reliably predict the right output for almost any input. All right. So next is step-by-step processing. What happens in the milliseconds between your prompt and the AI response? Okay. It follows a very specific four-step sequence. Now, the first one is tokenization. The AI doesn't see words, it sees tokens. It slices your text into small chunks that it can digest easily. The next step is what? Embedding. Now, it turns these tokens into numbers. It places these numbers in a massive high dimensional map where words with similar meanings are physically closer to each other. Then we have the next, which is what? Attention. This is the secret sauce. The model looks at your entire prompt to decide which words are the most important. If you ask for a bank report, the attention mechanisms knows you mean a financial institution, not the side of a river. Then we'll have the final step, which is what? Prediction. It calculates the most likely next piece of text based on the pattern it learned from those trillions of words. All right. So these are the processing steps of a large language model. To recap again, the first step is tokenization, followed by embedding, followed by attention, and finally it predicts your output based on your input. So moving on, we'll look at the power of predictions. So this brings us to a critical realization for any professional. An LLM is essentially the next word predictor. It doesn't know facts the way you and I do. It doesn't have a database of truth. But instead, it knows that words usually follow another in a specific context. Why does it feel like it's reasoning? Because it has so many examples of human logic, creativity, and professional tone that it can simulate them with startling accuracy. When you realize it's a statistical when you realize that it's a statistical engine rather than a conscious being, you become much more a better judge of when to trust it and when to verify its work. Now, uh, moving on, we have put back the curtain by understanding that LLMs are driven by data, architecture, and statistical probability. You now you are now ahead of 90% of the workforce. You can now approach these tools with realistic expectations. You know that hallucinations are just statistical engine taking a wrong turn. And you know that context is the key to getting results you need. Now that we understand how, we are ready to meet the actual tools. Let's move to our next topic, which is introduction to ChatGPT, Claude, and Gemini. See you in the next class.